up with our motto, let learning be a joy and teaching a pleasure. Here we are with a remote teaching and learning process to bridge the gap. Happy learning, students.
Hello students. Today we are going to study Mathematics Part 1 of Standard 10th, Chapter number 2, Quadratic Equation. In the previous video, we had done practice set 2.2 from sum number 1 to 6. In this video, we will see from sum number 7 to 12. Let us start with sum number 7. Sum number 7 is an activity based sum. As you see on your screen, the equation given is root 2x square plus 7x plus 5 root 2. They had said us to solve by using factorization method. Here let us see the equation. Whether the equation is there in the standard form? Yes, here the equation they had given us in a standard form. We will take the quadratic term and the constant term and we will multiply it. After multiplying, we will get plus 10x square. Now this plus 10x square, we are going to split it into two parts in such a way that after multiplication, that value should become 10x square, and after addition, it should become 7x. Those numbers are 5x and 2x. When we multiply these two numbers, it gives us 10x square, and when we add these two numbers, we will get 7x. Now let us decide about its sign. Let us decide about the sign of the greater value 5x. We'll get a sign of a linear term. In this case, it is positive sign, plus sign will be given to 5x. Now for deciding the sign of the smaller value 2x, we will check the above sign. Above sign is positive, which indicates us both the values should get the same sign. Therefore, 2x will also get a positive sign. Now let us come to our solution part. In the first box, we will write the value of 5x. In second box, we will write the value of 2x. Now we will take the common from first and the second term. It will be x common. Uncommon value will be written in that bracket. It will be root 2x plus 5. Now we will take the common from the third and the fourth term. Root 2 they had taken common. Uncommon values are root 2x plus 5. Now we will see both the values inside the brackets are same, means we can take this value as common and we will write in the first bracket root 2x plus 5, and in second bracket already they had written the values which are written outside the bracket x plus root 2. Now next line we can say either the first bracket or the second bracket will be 0. In the first dash we will write root 2x plus 5 equals to 0, and already for the second equation they had given. Now down, when we will solve, x equals to dash they had given. Already on the right hand side we have minus 5. Root 2 will also be shifted to the right hand side and it will become minus 5 upon root 2, which will be again written in that final answer. The root of the given quadratic equations are minus 5 upon root 2 or minus root 2. Sum number 8. 3x square minus 2 root 6x plus 2 equals to 0. Solution: 3x square minus 2 root 6x plus 2 equals to 0. Here the given equation is already arranged in a standard form. So let us start with multiplying the quadratic term and the constant. Here after multiplying we will get plus 6x square. After splitting this value, we will get a value which will be root 6x into root 6x. When we multiply these two terms, we get 6x square, and when we add, we get 2 root 6x. Now let us decide about the sign. The first term will get the sign of a linear term which is negative, and the second sign will be decided as per the above sign, positive, which indicates both should have same sign, so it will also get negative. Now let us substitute this value in our equation. It will be written as 3x square minus root 6x minus root 6x plus 2 equals to 0. Now we have to take common from the first two terms. Few of the students might find it difficult in getting common when values are given with root and without root. So let us see properly in a rougher how to take the common out of these two terms. First let us decide about the variable. Both the terms are having a variable as x, means x can be taken common. Let us decide about coefficient. First term is having a coefficient of 3 After factorizing 3, we will get root 3 into root 3. The second coefficient is root 6. When we factorize root 6, we will get root 3 into root 2. Means when we will observe that values, root 3 will be common in the coefficient 3 and root 6. Already x we had taken common. Now root 3 will be also common. Means common from the first two terms will be root 3x. Let us see for the third and the fourth term. Third term is having a variable, fourth term is not having a variable, means variable cannot be taken as a common. Let us decide about their coefficient. Third term's coefficient is root 6. When we factorize again, we get root 3 into root 2. And the constant value is 2. When we factorize, we get root 2 into root 2. Here when we decide about the common values among both will be root 2. So here third and the fourth term we can take common as root 2, which can be written as root 3x in bracket root 3x minus root 2 minus root 2 in bracket root 3x minus root 2 equals to 0. Both the brackets are same, will be written once. Root 3x minus root 2, and in second bracket the outer values will be written, which is root 3x minus root 2 equals to 0. Now we can say either the first bracket or the second bracket is equals to 0. We will try to shift the constant value on the right hand side. It will be written as root 3x equals to root 2, and on the right hand side also root 3x equals to root 2. Now root 3 from both the equation will be shifted on the other side, and it will be written as x equals to root 2 upon root 3 or x equals to root 2 upon root 3. Therefore our final answer will be written as root 2 upon root 3 or root 2 upon root 3 are the roots of the given quadratic equation. Sum number 9. 2m into m minus 24 equals to 50. Let us start with the solution. 2m into m minus 24 equals to 50. Here in this equation they had given monomial into binomial, means that 2m has to be multiplied with the bracket and will be written as 2m square minus 48m minus 50 equals to 0. After getting it in a standard form, let us get the value of a, b, c. Value of a is 2, value of b is minus 48 and the value of c is minus 50. All these three values are divisible by 2. Therefore, we will do dividing each term of the equation by 2. What we will get? We will get m square minus 24m minus 25 equals to 0. Again the equation is there in the standard form. We will multiply the quadratic term and the constant value. We will get minus 25m square, which further we will split and we will get it as minus 25m plus m. After substituting in that equation, it will be written as m square minus 25m plus m minus 25 equals to 0. Let us take common from the first two and the last two terms. It will be m common, uncommon will be m minus 25 plus 1 into m minus 25 equals to 0. Both the brackets are same, again can be taken as common and will be written as m minus 25 equals to 0 or m plus 1 equals to 0. Constant value will be shifted to the other side. It will be m equals to 25 or m equals to minus 1. Therefore final answer will be written as 25 or minus 1 are the root of the given quadratic equation. Let us move to sum number 10. 25m square equals to 9. Solution: 25m square equals to 9. Let us shift that 9 on the left hand side. It will be written as 25m square minus 9 equals to 0. The equation is not there in the standard form, but I can see both the terms what they had given are square of something or the other. So here the first term is a square of 5m and the second term is a square of 3. So we can write it as 5m the whole square minus 3 square equals to 0. Here we can apply a formula of a square minus b square and can be expanded. So here it will be written as 5m plus 3 into 5m minus 3 equals to 0. We had applied a formula of a square minus b square equals to a plus b into a minus b. Now we can say either the first bracket or the second bracket is equals to 0, means it will be written as 5m plus 3 equals to 0 or 5m minus 3 equals to 0. Let us shift the constant value on the other side. It will be written as 5m equals to minus 3 or 5m equals to 3. then 5 will also be shifted on the other side and it will be written as m equals to minus 3 upon 5 or m equals to 3 upon 5. Then the final answer is minus 3 upon 5 or 3 upon 5 are the roots of the given quadratic equation. Sum number 11. 7m square equals to 21m. Let us start with the solution. 7m square equals to 21m. 21m, which is there on the right hand side, will be shifted to the left hand side and can be written as 7m square minus 21m equals to 0. Here the given equation is not there in the standard form, but one thing we can see, out of the both the terms 7m square minus 21m, something can be taken as common, and here when we take a common, it will be 7m into m minus 3 equals to 0. Means in this line we had written monomial 7m into binomial m minus 3 equals to 0. Means we can say either the monomial or the binomial can be taken as 0. Means either 7m equals to 0 or m minus 3 is equals to 0. Now from equation 1, 7 will be shifted on the right hand side, and from equation 2, minus 3 will be shifted to the right hand side. It will be written as m equals to 0 upon 7 or m equals to 3. Now 0 upon 7 means 0. Therefore we will write m equals to 0 or m equals to 3. Therefore the final answer will be 0 or 3 are the roots of the given quadratic equation. Sum number 12. M square minus 11 equals to 0. Solution: m square minus 11 equals to 0. Again here the equation is not given in the standard form, but we can see m square is the square of m and 11 is the square of root 11. So it will be written as m square minus root 11 the whole square equals to 0. Again here we can apply a formula of a square minus b square. After applying a square minus b square formula, we will get m minus root 11 into m plus root 11 equals to 0. And the formula what we had applied, that is a square minus b square equals to a plus b into a minus b. Again bracket will be splitted and can be written as m minus root 11 equals to 0 or m plus root 11 equals to 0. Root 11 will be shifted to the right hand side. It will be written as m equals to root 11 or m equals to minus root 11. Therefore our answer will be root 11 or minus root 11 are the root of the given quadratic equation. Here we completed practice set 2.2. I hope you all had understood practice set 2.2. Thank you.